Okay, let me reset my timer here. Alright, so we've got now a better guess at f value. And we've gone through the iteration process first. Okay. Through the iteration process, we found a good guess for the volumetric flow rate to be this. We've now found the Reynolds number and plotted on a Moody diagram that Reynolds number with our epsilon over d to give us a better guess at f. So we're seeing f to be just over 0.031. I'm sorry, 0.03, just over 0.03. So I'm going to say Reynolds number and then with an epsilon over d of approximately 0.0005. These two together are going to give me an f value right around 0.031 using a Moody diagram. What are we doing here? Well, again, now given these, I've got a better guess at f. Now with a better guess at f, I can go back up here. I can go back into this equation. This is the only thing that's changed now, is instead of 0.017, I'm now saying my f is 0.013. So now I can say a better guess at v is going to be the square root of these. None of these values up here change. So now I can say this is 0.024246. Units there were feet to the 6th divided by seconds squared. So the unit's going to work out. Divided by this quantity of 8 plus, now I've got a better value for f, 0.031 times the 6,400 that was constant there, plus the 20.8. So if I run that up, I never said it was easy. Anybody that told you engineering was easy, they lied to you. Sorry, it wasn't me. 0.0. Now let's do the denominator first, because I'm using just a standard scientific calculator. So 0.031 times the 6,400. Do that middle term first. Okay. Add to that the 20.8 and the 8. You could add that in one step if you like. 28.8 is fine. I'm going to invert that and multiply that to the numerator. 0.024246. Square root that. So we're estimating a volumetric flow rate with that new f value of 0.01033 cubic feet per second. Now we stop there. Do we stop there? No. Notice the change here. We started with a really terrible first guess at the f value. Right? We guessed the f value initially was 0.17. This is going to be a much better guess at the f value. This gives us a much better guess at the v value. But I'm still seeing, so this is from one guess to the next of v, I'm seeing a big change. I'm seeing a change in the second significant figure. I need to do it at least one more time. That's probably all I'm going to have to do is one more time. But let's see. Okay, so this is page 5, if memory serves. Right. So now we're to page 6. Right, so page 6 says that if I've got v equal to 0.01033 cubic feet per second, if that's the case, then what did we say? I said, well, if that's the case, my Reynolds number, we said, is, I've simplified it down to where I can say this 1.225 times 10 to the 6 multiplied by my v dot. I'm not going to worry about units now because we've gone through the loop once. We know the units work. So I'm going to drop them now. So that's going to give me my Reynolds number. Okay, I've got my v dot there. So let's just multiply that by this 1.225 e to times 10 to the 6. So my Reynolds number, a better guess for my Reynolds number, even lower, 12,654. So about 1.2 times 10 to the 4. So that with my epsilon over d of about 0.0005, we said. that will give me a better F value using a Moody diagram. So we'll go back. See if we've got another color here. Blue's okay. All right. So we're real close now here. It's not going to change much. Maybe come up just a tiny bit. So just a little higher, 0.032 I might suggest. It's a logarithmic scale, right? So it gets a lot closer as you get to this 0.04 up there. I wouldn't go up very much. Maybe a 0.033 if you really like. If you want a really good estimate, run it through the Colebrook equation. I'm not going to do that here. You're seeing how much calculation I'm doing just using the Moody diagram. It's even more with the Colebrook, although it does simplify and everything is constant. Okay, so what do we do? Well, now we can find B again. So if you've got a really nice calculator, right, you can have this expression entered into your calculator, and the only thing now you're going to change is this one value. Okay? So I'm not even going to write it out. I'm just going to use this as my template now with this F value in place of the 0.031. So I'm just going to use that now. So I'm going to take 0.033, multiply by the 6400, add to this the 20.8, and add to it also another 8. I'm going to invert that, multiply that to the 0.024246, and I'm going to square root that. And notice what we get there. We get V dot of 0.0101 cubic feet per second. And this is what I would suggest use. If the third significant figure is the only thing that changes, you're done. If we went through and found my Reynolds number again, I mean, how much difference are we going to see in the Reynolds number? Not much, right? I mean, we could run it through real quick. It's not going to take any time. This is my flow rate multiplied by this constant over here. That's 1.225 times 10 to the 6. That's my Reynolds number. Notice my Reynolds number has not changed. That means I'm going to get essentially the same F value. That means this is my volumetric flow rate. That's a lot, I know. That is a lot, but that's how it goes. And again, it's not easy. So look, all of this, so page 6, page 5, page 3, page 5, page 4, and page 3, and I said back here, I said, look, guys, here, right, all this stuff you see here on the first page and everything here, and that's probably 60% of your points right there. This is going to get you to 70%. Getting your KL value is going to get you another 10%. So 10% here, 10% there. You're at 80%. You got all this together, right? So here's going to be 80%. This last, these next, all of this computations, 3 pages, 2 pages of computations to get the last 20%. That's how I grade. So again, yes, it's a lot. Yes, it's intimidating. It's not easy. That's okay. Show me you know how to set it up. Show me you know how to get all of the unknowns to where all you have to do now is the hard computations, and I'm going to get you to a passing grade. Okay? If you have questions, comments, complaints, shoot me an email. I'm sure the internet's going to leave me all kinds of fun comments down there in the comments section. That's okay. I don't care. But for you guys in my class, email me. Find me in the chat room on Canvas. We can set up a Zoom conference. I'm happy to work with you guys. I just need to know what you need from me. But anyway, that's how this one works. What does this help us? What does this do for us? Okay. Well, let's do this. Let's convert. Let's say 0.0101, and let's convert that volume. That is in cubic feet. And most of us probably think in gallons, right? So it's this many, approximately 0.063 gallons for every second, multiplied by 60. That's about 3.7, 3.8, we'll say 3.8, almost 4 gallons every minute. All right, so about 4 gallons a minute out of one garden hose. All right, if I'm really trying to get this, I can just leave that overnight, right? And that's with 5 foot ahead. Now, ideally, as this head decreases, all right, remember where this guy went. I've got a 5 in the numerator here in the square root. So as this elevation decreases, as I drain more and more out, this number decreases, meaning the flow rate decreases. Okay? So this is a starting value of about 3.8. But that's okay. I don't have to pay for this. Right? I'm not pumping, I'm not using electricity. This is just gravity doing its thing. And if I'm really serious about this, I just put another hose in here. I put 2 or 3 hoses in here. And if 2 or 3 hoses can get me anywhere between 2 and 4 gallons per minute per hose, I'll just leave that overnight, and that'll drain this out. I can get it down pretty low, not having to do much. I don't have to get in there with a cup and bail water out. I don't have to do much work to do that. It's kind of free energy, so to speak. Just letting gravity pull the water out of my pool, and that's a good way to do it if you're not in a hurry. Does it do it fast? No, it doesn't. But it doesn't. Alright guys, I think that's plenty. Stay safe out there. Loud pops are coming. Stay safe out there. Wash your hands. Stay healthy. I will see you guys in the future. Alright.